Okay, 4.4 is evaluating logarithms and change of base. First thing we need to talk about, when you see a log without a base, the base of the log is 10. And the reason for that is the base of our number system is 10. Think about it, we have the ones place, the tens place, the hundreds place, the thousands place. Even on the decimal side, the tenths, hundredths, all of those are multiples of 10, which is why our number system is based on the number 10. So when you see log of something like 10 cubed, this is really log base 10 of 10 cubed, in which case you could bring the 3 down front, 3 times log base 10 of 10, and we know anytime a log's base and a number match, it's 1. It's 3 times 1, which is 3. The same can be done for decimals. This is the tenths, hundredths, thousandths, 10,000ths place. This is really log of 1 over 10,000. Now there's a few ways to do this. We can either turn it into 10 into a power, or we can use division. And 10,000 is 10 to the 4th. The 4 would come down, and this turns into 1. So this is 0 minus 4 times 1, which is negative 4. Alternatively, you could have called this thing 10 to the negative 4th power, because that's represented by the number of times behind the decimal place that you see there. So it works the same. One other way that some of our rules from 3.3 can help us, 4.3, is log of 5 plus log of 20. We don't actually know those values. We know that addition can become multiplication inside a logarithm, and 5 times 20 is 100. Now if we do log base 10 of 100 being 10 squared, this is going to be 2. Now, in your calculator, you've got 2 buttons, only 2 kind of logarithms. So we have to make do with that. There's a log button and an ln button, which we'll talk about in a little bit. So for things like log of 142, which aren't even, you'll put them in your calculator. If you don't have a calculator with you, you can of course put them into Google. Log of 142, just keep in mind how many decimal places you're supposed to be rounding to. This is 2.152. Log of 0.005832 is negative 2.234. And log of 2347 is 3.371. Now, you technically may not know if these are exactly right or not, but we can kind of reason our way through them. 142, what powers of 10 is it between? 100 and 1,000, which is 10 to the 2nd and 10 to the 3rd. It's a little bit closer to 100 as well. So we're expecting our number to be between 2 and 3, the powers for 10 in that case, and a little bit closer to the 10 squared, which it does do. So keep that in mind. You can always use like a logical check, or is my number making sense? Now remember, if there's a negative inside a logarithm, you can't take it. Anything less than 1, like this decimal here, will give you a negative answer. Anything greater than 1 should give you a positive answer. And of course, if it's exactly 1 on the inside, it will give you 0. Now, besides the log, we mentioned the ln button a minute ago. The natural log is the second most important logarithm, maybe even more important than log base 10. It is the logarithm base e, but it's the second one in the calculator. So when you see ln, it's log base e. Now, we talked about e a little bit with the compound interest before, where it comes from with continuously compounded interest. So just like log of 10 to the x equals x, because they cancel, 10 to the log of x is x, ln of e to the x is x, and e to the ln of x is x. So when you have something like ln of e to the 4th, the ln and the e cancel out, because this is really log base e of e to the 4th. And the log base e of e cancels if the 4 goes down in front with our logarithm exponential rules. So this is just 4. Similarly, the ln of 1 over e to the 7/2 is the ln of 1 minus the ln of e to the 7/2. This is 0 because it's still a log. And just like from previously, this is going to be 7 halves. 0 minus 7 halves is negative 7 halves. The ln of the fifth root of e is really the ln of e to the 1/5 power. So remember what happens with exponents and roots, which is just 1/5. Now, just like logarithm, if you have some weird numbers, you put them in the calculator. Let's not do all of them. The ln of 2347 is 7.761, and we'll do the decimal as well to demonstrate that the same rules apply. The ln of a number less than 1 is going to be negative. The ln of a number greater than 1 will be positive. So it's the same rules for putting in the calculator as before. So the question might arise, well, what happens if I have a logarithm that's not nice and friendly and it's a log of any other base besides those two? We have the change of base formula. That says the log base a of x is the log base b of x divided by the log base b of a. So you can change the base and use your old base and what's inside your logarithm as the new form. So if you have log base 3 of 7, obviously 7 is not an even power of 3. You can change it to the log of 7 over the log of 3, so log base 10 of 7 over log base 10 of 3, or the ln of 7 over the ln of 3. You can use either one. So if we're just rewriting these without evaluating, the log of base 37.2 of 456.78 can be rewritten as the log of 456.78 over the log of 37.2. And besides that, we can also use the ln. We'll do the ln on the next one. Log base 0.034 of y, if we wanted to use ln, it would just be the same thing. The ln of y over the ln of 0.034. So your base of your old logarithm always goes in the denominator. Even with algebra, this could be log of x to the fifth plus 2x plus 1 over log of x squared plus 3. But if you have an algebraic case, please don't try to factor and cancel things. You can only do that if they're inside the same logarithm. So if I wanted to evaluate things in the calculator, I change the base and then I put it in the calculator. So log base 5 of 17 is log of 17 over the log of 5. And that I can put into the calculator or Google to get 1.760. That means 5 to the 1.76 power is 17, and you can always check that. Similarly, if I wanted, let's skip beat 2, log base pi of 47 is log of 47 for log of pi. .363, and actually we can do this one as well. Log of 0.1 over log of 2, because it does confirm what we already know, that when the number inside a logarithm, regardless of the base, is less than 1, I should get a negative. So let's see what happens when I do this. We get negative 3.322. So the last thing we want to talk about real quick is the fact that logs and exponentials are inverses. So it helps us simplify equations without calculators. When I see e to the ln of 4x, when I raise e to the power of ln, these still cancel, and what's inside the logarithm is all that's left. So this is 4x. E to the ln of 54 is 54. E to the ln of 1 over e to the fourth, e and ln will cancel, but it doesn't cancel out all the e's, only one pair. So it's still 1 over e to the fourth. Lastly, evaluating functions, the same thing could still happen. F of x equals ln of x. So f of e to the negative 1/2 would be ln of e to the negative 1/2. And then here the ln and the e would cancel to give you negative 1/2. Similarly, f of 1 over e to the pi squared plus 3 pi minus 2 is the ln of 1 over e to the pi squared plus 3 pi minus 2. If I flip that to the numerator, it changes all the signs of the power. So that's e to the negative pi squared minus 3 pi plus 2. And of course, from here, the ln and e cancel out. And that's really all that there is in 4.4. It's a pretty easy, mostly calculator section. And 4.5 is the last section in the chapter next.